The lesson outcome for this video is, I can multiply and divide rational expressions. Okay, so before we look at one that's a little bit more complicated, we're going to look at a good old fraction times a fraction, and that is multiplying rational expressions, because this is a polynomial over a polynomial, which makes it a rational expression, and we're multiplying it by another fraction, which is a rational expression. So technically this is an example of the outcome, however, it is a simplified version. Here's the thing you have to remember. When multiplying two fractions, we multiply across the numerator and multiply across the denominator. We do not, and remember this is important, we do not cross multiply. That would happen if there was an equal sign right here and we were solving. So what we do is we multiply the numerators 1 times 2, and we get our answer over here of 2. And we multiply 2 times 5 in the denominator and we get 10. And 2/10 is technically the correct answer, but it is not as simplified as possible. To simplify this, we can divide the top by 2 and the bottom by 2. They are both divisible by the same factor. So 2 divided by 2 is 1, and 10 divided by 2 is 5, and we have arrived at our final answer, most simplified answer. Now, I have the same exact problem right here, and I have this written down again because I want to show you that we could have done this problem a little bit easier and not taken this many steps to do it. And the thing is what we ended up doing is dividing by a factor of 2 here, right? Because if you look at the problem as a whole, we have a 2 in the numerator and a 2 in the denominator, which means that we could have canceled first, or simplified first, before actually multiplying. And that's going to be important for what we do on the next screen. So if we want to cancel or simplify first, we can do that. Because what we can look at here is we can look at this multiplication right here of fractions. We can look at that as one big fraction if we want to. We can change that into one fraction with multiplying up here and multiplying down here. Which means that we can simplify factors that exist in both the numerator and in the denominator. Since there is multiplication going on here, they are factors. So we can cancel this factor of 2 with this factor of 2. And now, if we multiply across the numerator, 1 times, technically when you cancel, they're 1s. So 1 times 1 is 1 over 1 times 5 is 5. And we arrived at 1/5, which is the same answer as we got up here. So, simplifying first is typically going to make it an easier problem than simplifying later. Okay, so let's take a look at this example here. Now, it looks like there's a lot going on here, but what it is a fraction times a fraction. And like I said on this previous screen, since it's multiplication, and be very careful that you're paying attention to whether it's multiplication or division, because we're going to talk about division on the next screen. If it's multiplication, we can just think of this as one long fraction bar with multiplication in between. Okay, so everything now in the numerator is a factor, 2 times x plus 8 times x plus 1. We've got 1, 2, 3, 4 factors. 2 of them are binomial factors. In the denominator, we have a factor times a factor times a factor times a factor. 4 factors, again 3 of which are binomial factors. But all that doesn't really matter as long as we understand that they're factors and that we can cancel out factors that exist in the numerator and in the denominator. So if we look around for common factors in the numerator and denominator, the first thing I notice is that there's an x plus 1 in both the numerator and in the denominator. So we can cancel those out, or in other words, make 1. It turns into 1 over 1. I next wanted to cancel out this x plus 8 with this x minus 8, but notice plus and minus make these different factors. The last thing I notice is I do have a common factor of x right here, and we can cancel those out. There's nothing else we can cancel at this point, so we're going to write our final answer. In the numerator, we're left with a 2 and a binomial factor of x plus 8. And in the denominator, we have an x minus 6, and we have an x minus 8. Again, unless we can cancel out an entire factor, we cannot cancel. So we are done. This is our final answer here. We can't cancel these 8s because they are terms. We can't simplify this 2 with this 6, for example, because 6 is a term of a binomial factor. So this is our simplified answer. Our final example is an example of division. Now, I'm going to actually move this down here for a second. Before we look at this example right here, I'm going to ask you to think back to when you used to divide fractions. Again, I'm going to use 1 over 2 divided by 2 over 5. That's the one we did last on the first screen here. So here's the thing you have to remember, hopefully you do, is we divide fractions by actually changing them into multiplication problems. You might have heard the phrase, keep it, change it, flip it. Because division of a fraction means that we need to multiply by the reciprocal. So I'm going to change this into 1/2 times, instead of multiply, and then I need to take the reciprocal of 2/5, which means to flip our fraction around, and we're going to have 5 over 2. Again, keep the first fraction the same, change the division to multiplication, and change the 2/5 to 5 over 2. And now, once again, we can just multiply. We can cancel out common factors first if we want to. We can make this one long fraction bar with multiplication in the numerator and in the denominator. And we can cancel out common factors. Now, remember, they have to be common with the numerator and in the denominator. I have a 1 up here, no 1s down here. I have a 5 up here, no 5s down here. We have 2's down here, but we cannot cancel them, don't do that, unless there's a 2 in the numerator. So there's nothing to cancel, so we just multiply 1 times 5 is 5, and 2 times 2 is 4, and that is our final answer. So that's the same thing we have to do down here when we see division of rational expressions. We need to keep the first fraction as it is. So we're going to keep this fraction as it is. We're going to change this division to multiplication, and we're going to flip this fraction. Now, just like I did up here, you could rewrite the whole problem over here, but what I find to be fine for most students is to change our division sign right here, change the division sign to multiplication. There's a big dot there for multiplication, as long as I remember to flip my numerator and denominator. So I'm going to move the 2 to the denominator, and I'm going to move the 5 times x minus 3 to the numerator. So I kept the first fraction, changed the division to multiplication, and flipped my numerator to the denominator and my denominator to the numerator. And now it's just one big multiplication problem. Again, you can consider this as big multiplication fraction bar. Put the dot in there and put a dot in here. And we can cancel anything that we have in the numerator and the denominator, common factors. So I see this 2 right here exists down here as a factor as well. I see an x minus 3 in the denominator and an x minus 3 in the numerator. And that is all I see that I can cancel. Again, please note, I can't cancel this x right here with this x because this is a binomial factor. You can't cancel terms. So if I want to rewrite this, make sure you get every factor that's remaining. Right here I've got an x plus 1 remaining that hasn't been canceled out. I also have this 5 right here. Do not forget that 5 factor. It's super important. I'm going to put that out in front because I usually put monomial factors in the front. In the denominator, I have an x left, and that is it. And that is our final answer in simplified form.